Hello. For this video, we're going to investigate a problem involving distance, speed, and bearing. The problem reads, a plane has a speed of 500 miles per hour. It travels north 35 degrees west for 30 minutes and then changes its bearing to north 50 degrees west for 1 hour and 45 minutes. Determine the distance and bearing that the plane would need to travel to get from its final location back to a starting point. Now, to solve this particular problem, we would need to consider the distance that the plane has traveled during each particular bearing. Now, to determine this distance, we would have to consider the fact that we're given the speed and we're given the amount of time that the plane has traveled for each bearing. We can actually use this information and a particular formula to determine what the distance is. Now, this formula is distance is equal to rate times time, and rate is just another word for speed. So, so we see that the speed is 500 miles per hour. We can actually plug that directly into the formula, but the time of 30 minutes, we would have to convert that into hours before we can plug that into the formula. Now, to convert 30 minutes to hours, we could just take 30 minutes, put that over 1, and then multiply that by 1 hour per 60 minutes. And we see here that these units cancel. So we're going to have 30 over 60 hour. And then we can simplify this by dividing both the numerator and the denominator by 30, get 1/2 hour. So we know that the time is 1/2 hour. And since the time is now in hours, we can plug that into the formula. So we get 500 times 1/2, which is 250. And the distance is in miles because the rate was in miles per hour. So the distance has to be in miles. So it's 250 miles for the first bearing. Now, for the second bearing, we see that the plane traveled for 1 hour and 45 minutes. The 1 hour part, that's already in hours, but we need to convert the 45 minutes into hours. So we'll take the 45 minutes, put that over 1, and multiply that by the conversion factor, 1 hour per 60 minutes. Then we can cancel out these units. So we get, let's see, well, we multiply 45 times 1 to get 45, and then 1 times 60 to get 60. So we get 45 over 60 hour, and we can divide both the numerator and the denominator by 15. So 45 divided by 15, that's 3. 60 divided by 15, that's 4. So we end up getting 3/4 hour. Now, um, we can convert the 1 hour 45 minutes into 1 3/4 hour because we take the 1 hour and then we just add the 45 minutes to that. Well, the 45 minutes is 3/4 hours, so it becomes 1 3/4 hour. Then we can convert that to an improper fraction. So to convert this from a mixed number to an improper fraction, we would multiply 4 times 1 and then add 3. That gives us 7. And then we put that over the denominator of 4. So 1 3/4 equals 7/4. So 1 3/4 hours is equal to 7/4 hours. Then we can take the 7/4 and just plug that back into the formula. So we multiply 500 times 7/4. That gives us 875, and the unit is miles. All right. So now we can actually take the information that we have and try to like see what we can put onto the triangle. Now the thing is the plane begins by traveling north 35 degrees west. So if we consider like the direction the plane is going, if we draw like a cross like this, we can actually make an angle that's like 30 that's like north 35 degrees west like this because it's like going 35 degrees to the west from the north. Considering that the north is like straight up and the west is like to the left. So it's like you have to go straight up and then you have to um place your angle at 35 degrees west. And then the distance that is traveled is this line here. And we already determined that that is supposed to be 250 miles. So we can just put 250. So this particular side is 250. And then we need to travel north 50 degrees west for 1 hour and 45 minutes. So we calculated that the side length is supposed to be 875. So so basically this is like north and then 50 degrees west and then we have 875, which is this particular side. Now the the line segments aren't to scale here, but it really doesn't matter concerning the scaling because we're just concerned with the numbers. All right. So now let's go ahead and see what else we can input. So yeah, so we have this angle here that's 35 degrees, and this angle here is 50 degrees, and that's really all we can state at first. But there's other information that we can just infer because like if we're dealing with this particular cross here, and we know that this part is 50 degrees, this part here has to be 40 degrees because these lines are perpendicular to each other. So this 50-degree angle is complementary to this 40-degree angle here. So this angle must be 40 degrees. And also we already know that this one here has to be 90 degrees because we're dealing with the right angle. Now this particular angle here, to determine its measure, we can use what's called alternate interior angles. Um, so basically, if you have like this line and this line as parallel, and you have a transversal that intersects both parallel lines, you um, can actually consider that this angle and this angle to be alternate interior angles, and that is a concept from geometry. So basically, if you know the measure of one of the alternate interior angles, then the measure of the other one has to be the same. So if this is 35 degrees, then this one has to be 35 degrees. All right, so now we know these three angles here, and then if we want to add them up, we can. So we have 40 degrees plus 90 degrees plus 35 degrees. That gives us 165 degrees. So that means that this entire angle here is 165 degrees. So now, if we are considering this particular angle here, then we also have like this side over here, which really just represents like the distance that the plane has to travel to get from its final location back to a starting point. So basically, if we know what this angle is, and then we know what this side is, and we know what this side is, we can actually determine what this third side should equal. And we can do that using the law of cosines. So, so the formula for the law of cosines that we can use is c squared is equal to a squared plus b squared minus 2ab times the cosine of c. And we can just plug in the values that we know. So we're trying to find c. Well, we can plug in lowercase a and lowercase b. Those correspond to the sides that are like opposite of angles A and B. So the side opposite of angle A is 250. The side opposite of angle B is 875. So so we can plug in 250 squared plus 875 squared minus 2 times 250 times 875 cosine of, and then it's the angle C. So the angle C is 165 degrees. So now we can just simplify this a little. So we have c squared is equal to 62,500 plus 765,625 minus 437,500 cosine of 165 degrees. Then if we want to, we can put all of this into the calculator. If we have a certain like scientific or graphing calculator, we but if we want to just like compute these like using the order of operations, we can do that as well. But suppose we put everything into the calculator, we'll end up with this particular value, 1,250,717.549. Now, if we want to um if we want to find the value of C, then we'll need to cancel out this square. And we can cancel this out by taking the square root. So now we have C is equal to the square root of that same value. And if we find the square root of that, we get C is equal to 1,118.35484. All right. So now we know what this particular side is of the triangle. And this side represents the distance that the plane would need to travel. So we can go ahead and answer that particular part of the question. So the distance is 1,118.35. And of course, if we round it to the nearest hundredth, we can stop at the 5 because the next digit is a 4, and then miles. All right. So next, um, we need to determine what the bearing would need to be. And to do that, we're going to have to find this angle of the triangle, which is angle A. And once we find angle A, we'll be able to determine, well, we'll need to find this angle of the triangle, which is angle A. And once we find angle A, and once we find what this angle is, we'll be able to determine what the bearing should be, which is represented by this angle. To find angle A, we can use the law of sines, which is sine of A over A is equal to sine of B over B, which is equal to sine of C over C. And this particular trigonometric identity actually will help us determine what our missing angle A is. So this identity has three different parts, but we're only going to use two of them when we actually solve um for angle A. First part is the part that includes the angle A, so we're going to use that part. And let's see, and the second part that we need is going to include the angle C. So we already know that angle C is 165 degrees. And then it's also going to include the side C, which we just found here. I would recommend to use the calculation that has the more decimal places, um, so that our final answer is more precise. So now, um, we can go ahead and plug in the values that we need. So essentially, we don't need this particular part of the formula, and we can go ahead and solve this equation that is resulting. So if we multiply both sides by 250, then basically the denominator on the left side cancels out. And on the right side, we have 250 sine of 165 degrees over 1,118.35484. And if we want to get A by itself, we would not divide both sides by sine because the sine of A is a trig function, so these are not being multiplied to each other. What we would need to do is put the A on the side by itself and set that equal to the inverse sine of this expression. So whenever we're trying to get the angle by itself, we'll need to write the angle as equal to the inverse trigonometric function of whatever the expression was that the sine of the angle was equal to. So in this case, A is equal to inverse sine of this particular expression. And then we can put this into the calculator. Now we have to make sure that the calculator is in degree mode and not radian mode, because if the calculator is in radian mode, then we would not get the correct answer. So once we input all of this into the calculator, then we're going to get A is equal to 3.32 degrees. Or we can go ahead and put that as our angle here. Now, to get this particular angle, we can use alternate interior angles again. So we already know that this angle is 40 degrees, and this line is parallel to this line. So that means that this angle and this angle are alternate interior angles. So if this one's 40 degrees, then this one has to be 40 degrees as well. And then also this entire angle here, because we're dealing with the perpendicular lines again, the entire angle here is 90 degrees. So we can just take the 90 degrees and we can subtract the 40 degrees and subtract the 3.32 degrees. And that will give us 46.68 degrees. So now we know that this angle here is 46.68 degrees. And from there, we can state what the bearing is. So it appears that in order for the triangle to get from its final location back to a starting point, we would have to travel at a bearing of south and east 46.68 degrees. So it's south and then 46.68 degrees east.